Number 40's derivative is negative e to the 1 minus x. 42 is negative 2x e to the negative x squared. 44 is negative x squared e to the negative x plus 2x e to the negative x. 46 is 6 over t cubed times e to the negative 3 over t squared. 48, I rewrote first, then I did the derivative, and got e to the x over 1 plus e to the x plus e to the x over 1 minus e to the x. 50, I rewrote first and got e to the x minus e to the negative x over e to the x plus e to the negative x. 52, I split apart and then did the derivative and got half e to the x a half e to the negative x. 54, I got x times e to the x. 56, I got e cubed over x. 58, I got 1, because I simplified it first. 88, I got e to the negative x to the 4th plus c. 90, I get 0.63212. 92, 2/3 e to the x cubed over 2 plus c. 94, negative half e to the 1 over x squared plus c. 96, a half ln, absolute value of 1 plus e to the 2x plus c. 98.63212. 100. I got ln, absolute value, e to the x plus e to the negative x plus c. 102, negative 2 over e to the x plus e to the negative x plus c. 104, e to the x plus 2x minus e to the negative x plus c. 106, a half e to the secant 2x plus c. 108, x squared minus x plus c. Holy cow. That was a fun assignment. So if you have questions over those, please come with them for next time. The next thing that we're going to be doing are exponential equations. This would be a number. We're going to do logarithmic equations. Then we're going to do the antiderivative of exponential equations. So I'll let you copy those down. And then when you're ready, unpause the video. So here we have 4 to the x. So if we look at those 3 properties that we just wrote down, this would fall under the exponential equation category since x is an exponent, hence exponential. So we're going to follow that first rule. I'm going to go ahead and label what a and u are. I'm going to say a is 4 and u is x, so du is 1. So if we use the little formula that y prime equals ln a times a to the u du, ln a is 4, ln 4, times au, so 4 to the x, times du, which is 1. So you can put times 1 there if you wanted, and you're done. So see if you can say what a, u, and du are in this exponential equation. You should say a is 5, u is x minus 2, and du is 1. So we're going to do the derivative, ln a times a to the u times du, and you're done. What? Now we got x in a different spot. So we got x squared times 2x. So this is not an exponential, that is, and you have x in 2 spots. You're going to have to do product rule. So x squared is your first term and 2x is your second. X squared just becomes 2x, basic old rules. 2 to the x, however, you have to state what a, u, and du are to be able to do it. So a is 2, u is 1, du is, du is 1. I had that flipped. So we have ln a times au times du. So now we get a crisscross. So we get this long version, x squared ln a times au plus crisscross here. That does not combine. You get 2x times 2 to the x, or you could reverse your order there. See if you can do this one on your own. X is in 2 spots, so you should do the product rule. For the top one, we're going to say A is 2, U is negative X, so du is negative 1. So we got ln A times AU times du. Here we are going to say that we have cosine of u, so its derivative is negative sine u, with u being pi x, so derivative of u is pi. So we just used a lot of rules. We used the chain rule right here, we are using the product rule, and we also using our new rule up there, and we're using the rule for cosine. So we got negative sine of u, which was pi x, times u, which is pi. Alright, so crisscross here. So we got 2 to the negative x times negative pi sine pi x plus crisscross here. We got cosine pi x times, I'm going to put the negative out in front, negative ln 2 times 2 to the negative x. Fun times. Man, she changed from exponential to logs. So we have to know our log property, which our log property is log, with the a being there and the u being there. So again, we have to state what a is, and what u is, and what du is. The derivative for a logarithm is 1 over ln a times u times du, and you can put that du on top, and I typically do. So we're going to put du on top, 1 over ln a, which is 3, times u, which is x. And I'm going to put parentheses around it. And you're done. So see if you can do this one on your own. A red flag should be going up. You should see that this is a logarithm, so it can be split apart before doing the derivative. And we're going to subtract since it is division. And I'm going to move that squared out in front because it was an exponent. So for this first one, a is 2, u is x, du is 1. So this 2 just kind of follows down. So we got 2 times on top our du, which was 1. On bottom we got ln a times u, which was x. And you're done. For this one, we have a is 2, u this time is x minus 1, and du is 1. So we have minus, since our operation symbol was minus. We have on top du over ln a times u. And you are done. So, do this logarithm one on your own. You should rewrite with an exponent of a half, so it becomes a coefficient in front of a half. So a is 5, u is x squared minus 1, and du is 2x. You also could split that apart, now that I see that, and make it x plus 1x minus 1 and make it a little bit easier. But you don't have to, that would be extra credit. Okay, anyways, so we have a half times du, which is 2x, over our ln a times u. Notice the 2's would cancel, so you would get x over ln 5 times x squared minus 1. And you're done. There you go, you. Alright, so we got logarithm. So some of you are going to think, ooh, we can rewrite. But we have a logarithm over a whole thing there. So we have to use quotient rule. So we have 10 log base 4 of t, and we have t. So this one we got an a of 4, a u of t, and a du of 1. So we have 10 times du is 1, so over ln a times u. Here, derivative of t is 1. Crisscross, so 10 log base 4 of t plus, because you plus, you get 10t on top over ln 4 times t. And what do those t's do? They cancel. Alright, so now for the last part, which is antiderivatives. Our antiderivative was a to the x dx. So a, and I'm going to use u and du here rather than x, because sometimes that gets confusing. So I'm going to say a is 3, u is x, du is 1. So we have a to the u du. Its antiderivative is 1 over ln a times a to the x plus c, which the a to the x can go on the top. So I'm going to put a to the x on top. So I have 3 to the x, and I shouldn't say x, it should say u there, excuse me, u, over ln a plus c, and you're done. So try this one on your own. You should say a is 2, u is x, du is 1. So we have a, u, d, u. So we're going to have a to the u on top, so 2 to the x on top, over ln a plus c. So try this one on your own. You should say a is 5, u is negative x squared, du is negative 2x. So we have x, so we need negative 2, negative half. So we got negative half au du. So we have negative half times a to the u, so 5 to the u over ln a. So we can simplify that a little bit, put negative 5 to the negative x squared over 2 ln 5. You're done. So it appears in 2 spots, and like e, when e appeared in 2 spots, we couldn't say that our exponent was our u. So I'm going to say u is the bottom. So if u is the bottom, that means derivative of u, that's 0. This is our new property. So we have to say what a is 3, u is our exponent, and du is 2. So this is a to the u. Its derivative is ln a times a to the u times du. Wowzers. So on top, we have that, except for we don't have the ln 3 and the 2. So out to the front, we're going to do 1 over ln 3 and the 2. So we have 1 over ln 3 times 2. This top portion in the dx is du over the bottom portion was u. Antiderivative of du over u, lots of properties to remember, is ln of u. So u was 1 plus 3 to the 2x plus c. And this part just carries down. And you could actually figure out what that numerical value is if you wanted. I'm going to put that 2 in front, that way I don't think it's part of the back. And that is it for notes on this section. This chapter is a lot more difficult because there are so many rules that you have to remember and memorize. The more of the properties that you memorize, the easier it's going to be for you to recognize which one to use where. That's all I can tell you. Until you memorize them, it's hard to be able to know unless you have your list of all of them right there.